we were discussing sets, the topic of sets, and we were discussing that there are three different ways of describing a set. Number one is the descriptive method, that we studied that a set may be described in words. For instance means, for example, the set of all vowels of the English alphabets. Then the tabular method is that a set may be described by listing its elements within brackets. If A is the set mentioned above, then we may write A is equal to curly brackets start A E I O U curly brackets closed. Now this function, this particular set means that this is the set A and it has a lot of vowels, that is main vowels, that is A, E, I, O, U. And then we have set builder method. It is sometimes more convenient or useful to employ the method of set builder notation in specifying sets. This is done by using a symbol or letter for an arbitrary member of the set and stating the property common to all the members. Thus the above set may be written as A is equals to curly bracket start X and set of X bracket. Okay, now this vertical symbol is not bracket, it is actually written at X, and X is a vowel of the English alphabet. This is read as X is the set of all. It means that it means that basically X is the set of A is the set of is a vowel. A is the set of vowels, right? So this is the set builder method. That A is the set of in which it has X as a variable, is a vowel of the English alphabet, and you just have to write X/X is a vowel of the English alphabet. This is read as A. It means that if the it can come that how many ways are there to describe a set, then you will choose 3, and the multiple choice questions, that descriptive method, tabular method, and set builder method. Like, how can you actually write a set this or describe a set? For that we have 3 different methods: descriptive method, tabular method, and set builder method. Now in set builder method, it's written in the at the bottom that this is read as A is the set of all X such that X is a vowel of the English alphabet. The symbol used for membership of a set is this belongs to. Thus A belongs to A. Capital A means small a is an element of capital A, or A belongs to A, and C does not belong to A, right? As you can see that A, E, I, O, U, A belongs to A, E belongs to A, I belongs to A, O belongs to A, U belongs to A, but not C. There is not C. That's why C does not belong to A means C does not belong to A, or C is not a member of A. Elements of a set can be anything. Like, it is not necessary that elements might be only these letters or vowels. They can be anything, like people, countries, rivers, objects of our thought. In algebra, we usually deal with the sets of numbers. Such sets along with their names are given below. For example, n is the set of natural numbers. N, capital N, it will be equal to 1, 2, 3, so on. It is an unending set of series. W is the set of whole numbers. Z is the set of all integers. 0, plus minus 1 plus minus 2, and Z prime is the set of all negative integers, like minus 1, minus 2. It is a set. It means a set is like a box, and it contains a lot of stuff, right? Or you may say that it is a bag or a container, and it comprises means it consists of several things. Like if we now talk about capital O is the set of all odd integers. Odd integers means plus minus 1, plus minus 3. Odd numbers are 1, 3, 5, 7, 9, 11. And even numbers, capital E is the set of all even integers. It will be equal to 0, plus minus 2, plus minus 4. Even means 0, 2, 4, 8, 10, multiple of 2. And odd means multiple of 1, like 1, 3, 5, 7, 9, 11, etc. Then capital Q is the set of all rational numbers. where x slash x is equals to p over q, where p q belongs to integers and q is not equals to 0, as we have studied in our chapter number 1, rational numbers. Rational numbers are a series that end at some point, and they can be written in the form of p over q. That descriptive style is actually written in the form of like x slash x, p over q, where p q belongs to z means integers and q is not equals to 0. Then q prime, the set of all irrational numbers, x slash x is not equal to p over q, where p q belongs to integers and q is not equals to 0, because irrational numbers are unending numbers, as we studied earlier. Then capital R is the set of all, we have also studied capital R. It is the set of all real numbers, where the set of all you may say that real numbers is actually capital R, and it can also be written as rational numbers union irrational numbers, right? Now, what are equal sets? Two sets A and B are equal, that is A will be equal to B if and only if they have the same elements. Okay, that is if and only if every element of each set is an element of the other set. Like if capital A has 1, 2, 3, then capital B has 2 and 3, then you will see that 1 is also present in the B, 2 is also present there, 3 is also present there in both of them. Sequence does not matter. Therefore, the sets 1, 2, 3 and 2, 1, 3, they are equal, right? From the definition of equality of sets, it follows that a mere change in the order of the elements of a set does not alter the set. Like as I have said that the order or the sequence does not matter. In other words, while describing a set in the tabular form, its elements may be written in any order. Note, A is equals to B if and only if they have the same element, means if A is equal to B, they have the same elements, and if A and B have the same elements, then A is equals to B, right? And the phrase if and only if is shortly written as IFF. Then we have equivalent sets. Equivalent if the elements of the two sets A and B can be paired in such a way that each element of A is paired with one and only one element of B, and only one element of B, and vice versa. Then such a pairing is called a one-to-one correspondence between A and B. For example, if A is equals to Bilal, S and Jahzeb, and B is equals to Fatima, Umara and Samina, then 6 different in 1 into minus 1 correspondences can be established between A and B. 2 of these correspondences are shown below. Like equivalent sets will be like if we have Bilal, Ahsan and Jahzeb, they can be paired with Fatima respectively, Umara and Samina respectively, right? Like Bilal with Fatima respectively, Ahsan with Umara respectively means 1 by 1 and 1 to 1, and then Jahzeb with Samina. Okay, these are the pairings that can be done. Then Bilal can be paired with Fatima, Ahsan with Samina and Jahzeb with Umara. They can be paired with anyone, right? Then write down the remaining 4 correspondences yourselves. There they have said 2 sets of, like first of all you have paired Fatima with Bilal and Umara with Ahsan and Samina with Jahzeb. Then you could switch the people in the other set, and then you can again pair Fatima with Bilal, and that is written. I'm just describing this. And then Samina will be exchanged with Ahsan and Umara with Jahzeb. Or in the third scenario, Umara can be paired with Bilal, Samina with Ahsan and Fatima with Jahzeb, like just altering. Okay, 2 sets are said to be equivalent if 1 to 1. 1 to 1, it is not 1 minus 1, sorry, it is written as a 1 to 1 correspondence can be established between them. In the above examples, A and B are equivalent sets. 1 to 1 means like you are saying, yes, I have 1 chocolate and the person who is sitting in the B set has also 1 chocolate, so I can give him my chocolate and take his chocolate. Like this is 1 to 1, 1 with 1, not 1 with 1. It means 1 to 1 means like face to face, or single person with a single person, like that. Then we have the example number 1. Consider the sets capital N is equals to 1, 2, 3, so on, and O is equals to 1, 3, 5, so on. We may establish a one-to-one correspondence between them in the following manner. 1 2 3 4 5, then we can say that okay, these kind of questions might come as a short answer or an MCQ. Like if you have two sets, then establish the one-to-one correspondence between them, or as we have studied it, that explain them that why they are equivalent sets, or consider if they are equivalent sets, then write their one-to-one correspondence. Then one can be paired with one, two can be paired with three. Like this is the one-to-one, right? Thus the sets n and o are equivalent. But notice, like 1 2 3 4 5, they are 5 numbers, and on the other side there are also 5 numbers, so they can be. But as you can see in the question, it was written 1 2 3, so it is okay if it is written 1 2 3. You could also have made the pairing 1 with 1, 2 with 3, and 3 with 5. That is also okay. But the author has actually extended the set of n by writing 4 and 5, and in the O 1 3 5 7 9 odd numbers. Thus the sets n and o are equivalent, but notice that they are not equal, right? This is just one-to-one correspondence. Like I can take something which is also present in the other set with the person, but I will not taking that person, or that person is not me and I am not that person. Just one-to-one relationship. And remember that two equal sets are necessarily equivalent, but the converse may not be true. Like you can say that equal sets might be equivalent, but two equivalent sets might not be equal, right? Because in equal sets everything has to be equal. That is, two equivalent sets are not necessarily equal. Sometimes the symbol, and in equal sets, as we have studied, that the sequence does not matter. It does not matter that 1 is equal to 2 in the other set, as we studied in the equal sets definition. Only 1 has to be also present in the other set, 2 has to be present in the other set, and 3 has to be present in the other set. Okay, so sometimes the symbol this is used to mean equivalent. Light, it is a slight symbol of, like a, you may say that, a cloud. It is used to write that something is equivalent. Thus n is equivalent of o. That is, natural numbers are equivalent of this set of whole odd numbers. All odd numbers, not whole numbers, odd numbers.